Okay, so problem number one. Again, the concept was watch out, don't combine unlike terms, especially when a variable doesn't have an exponent, it's always one. So that was the tricky part number one. Tricky part number two, they throw in what? Actually, a couple things. First of all, they throw in the distributive property, right? Because I have a number in front of parentheses. Now, yesterday we talked about parentheses quite a bit, didn't we? Inside the parentheses here, I have two terms because it's separated by a plus or minus sign. We talked about that yesterday, right? Something new, anything with a set of parentheses, this is called a quantity. Okay, so a lot of times later you'll hear me use the word quantity. That's what's inside the parentheses. It's a quantity. Okay, so I have to distribute the 4x to the 5x. So what is 4x times 5x? 20x. Squared. Who said squared? Why?
Because you're multiplying x and x.
Yeah, when I'm combining like terms, I leave the exponents alone, right? When I'm multiplying variables, I have to add the exponents, right? So there's trick number two they throw into this problem. Now here's another trick that they. I'm sorry. Let's do the 4x times 4. 16x. Here's the third trick they put in here. A lot of students, they put this minus 18x, but they put it outside the parentheses. They're trying to trick you to distribute that 4x to the 18x. Don't do that because that 18x is outside of the quantity, outside the parentheses, right? Just bring it down. Now I do have some like terms. I have a plus 16x and a minus 18x, right? Nothing I can do with the 20x squared. 16x minus 18x minus 2x. That's it. That's as far as I can go with this algebraic expression because I have no equal sign. Number three, the wrench here, they throw in two distributive properties, right? I have to distribute in the first quantity, the 2 over the parentheses. The second quantity, I have to distribute that minus 3. So 2 times x, 2x, 2 times 1 plus 2, negative 3 times x, negative 3x. Negative 3 times minus 4, or negative 4, a positive 12. I do have like terms now. I've got the 2x and the minus 3x. I get a minus 1x. I'm going to use just minus x. If you put minus 1x in there, that's completely fine. Then I've got the plus 2 and the plus 12, which gives me plus 14. Okay. Questions, comments, concerns? Just throw them out there if you have them. All right, evaluate. Remember evaluate? We're evaluating expressions because there's no equal sign, right? You're going to be substituting in a value for the variable, right? Then you're going to simplify if needed. Okay. First one, Again, I like to put in parentheses wherever I see a variable. So I have my x value I'm going to be substituting, raised to the fourth plus 3 plus 3, and then I have my y. My x is negative 2. Substitute in negative x for the 2. My y is negative 8. So I'm going to substitute in negative 8 for my y. Now, um, if it doesn't tell you can't use a calculator, use a calculator. Because I put those parentheses in there, and if I type this in exactly in your calculator and the direction says, I can use one, use your calculator. If it says no calculator allowed or do it without a calculator, then you're just going to have to do it in your heads. Okay, negative 2 to the fourth. So I got negative 2 times negative 2 is positive 4 times negative 2 is going to be negative 8 times negative 2 is a positive 16. Positive 3 or plus 3 times negative 8, negative 24. Combine those, I get negative 8. Number 5, I have a fraction. I notice that I have 2 terms in the denominator because it's separated by plus or minus. So I'm going to go ahead and put parentheses on that right away so I don't mess it up. I'm going to rewrite this problem, and wherever I see a variable, I'm going to put parentheses. So I have x squared divided by parenthesis 2. Now I got a variable here, so I'm going to put in another set of parentheses, plus 1, and close off that parenthesis. Okay, my x is negative 3. So my negative 3 goes up here. And then my y is positive 2. So my positive 2 is going to go there. Now, since I use parentheses in all the right places, you can plug this into a calculator and it will give you the right answer. Okay? This one's not that bad to do in your heads, right? Okay, so I get negative 3 squared, 9. 2 times 2 is 4, plus the 1 is 5. Now, Algebra 1 and trigonometry, we like decimals. Pretty much everything else, and your math from this point on, except trig, they want you to use fractions. We want you to use fractions. Higher mathematics wants the fractions, even if they're improper. And the reason is decimals, a lot of times it rounds it off, right? Because it doesn't fit on the calculator. So that's an approximation. Sometimes it does, sometimes it doesn't. So we like to leave things as fraction in mathematics because this is an exact number. Whereas your calculator might spit out an approximation on the decimal, right? Okay, so let's look at the next one. So let's look at areas. Area of a rectangle. Does everybody remember what it is? What is it?
It's length times width.
Yep, length. This is a cursive L times width. Or I think you guys, many of you use base times height too. Okay. I'm going to use length times width because there's a b in here and it gets confusing. So I'm going to define my variables. Length is a plus b. And again, since I have two terms, I'm going to use those parentheses. My width is a. So my area is going to equal length times width. And I'm going to put my width on front. Remember, it's multiplication, so I can change order so that I can more easily use the distributive property. Okay, we do have substitutions for our A and B. My A is positive 8. I could use parentheses, and I should because I just told you I always do, but I'm not this time because this is really quite simple. My B is 3, so my area is what? Oh, I didn't. Sorry. So what's my area? 88, right? Okay, again, in Algebra 2, we would like for you guys to start using labels consistently. There are no labels here. There's no feet or inches, so we'll just call it units. And area is always going to be squared units, right? Perimeter is going to be our to the first power. Volume is always going to be third power, right? Okay, area of a triangle. Base times 1/2 base times height, right? Or base times height divided by 2. I think a lot of you use this one though. Okay, so I'm going to define my variables. My base is n plus 10. And I'm going to put parentheses around those because it's two terms. My height is n. Yeah, I know my n's and h's look alike. So my area is going to equal base times height, base n plus 10 times my height, n, all divided by 2. Okay, my n is 40. Again, this is really relatively simple, so I'm not going to rewrite everything in parentheses. So I have 40 times 40 plus 10, all divided by 2. So 40 times 50, this is 50, 2,000 divided by 2. So my area equals 1,000 units squared. Questions, comments, concerns? Now you guys are ready for word problems, right? Say, yay, Mr. D, word problems, yay. Yay, can't wait. Back when you were first learning word problems, and I'm thinking maybe fourth grade, they gave you a little process, right? And actually, this is the process that they gave you. You write a verbal model, then you kind of describe the variables, labels, they call them, and then you write an algebraic model. Maybe it's not fourth grade, maybe it's later. Then you solve it and give the answer. That's basically what you did way back in elementary school. And then as you got older and as teachers get lazier and lazier, they kind of say, kind of skip a lot of steps in here as long as you know how to do word problems, right? Well, most of you probably had trouble with word problems, and we never really took the time to follow this flow chart. We would just assume you knew it. So this is actually a pretty good flow chart, especially when you get into, now we're going to get into some word problems. They're not going to be too bad, but when you get into trig, um, this is a good process to follow. So if you can kind of get used to it and use it throughout, it will really help you if you continue on with math. Calc 2, in my day, it was like 75, 80% problems. And if you didn't follow this and trying to do it with calculus, it was miserable. All right. And also read the directions. In Algebra 2, we don't always have you guys complete the problem. Sometimes we'll just have you set up the problem, especially in systems of equations, because it takes so long to do one problem. So many times we'll just ask you to set it up. And that's what this one is doing. It says, what do the following variables represent? Okay, so we only need to kind of like define the variables, then we'll be done. All right, a salad bar charges $3.50 for an empty container. Then you'll be charged 45 cents per ounce of food. The following model represents the complete cost of your shopping trip to the store. So they want us to write out what T represents, write out what C represents, and write out what D represents. By the way, this is our mathematical model. Another one of those terms that probably didn't define it very well in Algebra 1. That's called a mathematical model. And in this case, it's actually an algebraic model because it has variables, right? Anything that has variables is algebraic. So what does T represent here? Anyone? Yeah, your total cost of the salad, right? Okay, what's the C going to represent? Looking at the problem, yeah, it's definitely going to have something to do with the empty container. Well, let me ask you this. What does a, because they're asking for the variables, what does a variable represent again?
A number?
A value, right? A number. Okay. Do we know what the cost is?
Yeah.
Yeah. So that's given. We know that. So we still have an unknown in here. What's that unknown? We know what the cost of each empty container is. Help them out.
Total cost.
Huh?
Total cost.
Well, we got our total cost. Well, ounces is more in over here for D, right? Think about this one little statement right there. $3.50 for an empty container. Yes,
Number of containers.
number of containers, right? Number of containers, good. Yeah, we already know how much it cost. What we're looking for, and they use the word and, is how many containers. We don't know. What if we get 2 containers, 3 containers? Whatever the number of containers is, we got to multiply by 350. So with this in mind, D is going to represent what? We know the cost per ounce, the number of ounces. Great, great. Okay. So there's our variables defined. And that's all the problem asks us to do. Seemed like a lot of work just for that. So let's go ahead and the next problem, number 2, they have us do everything. Okay, work out a whole problem. Okay, a personal trainer charges $20 per month for the clients plus a $17 charge per hour for each session of training. Yes, say that quick. Create an algebraic model. Again, the algebraic model is this, right? An equation that determines the total cost C for a single month of personal training for an unknown number of hours H. So they told us what variables to use here. So our verbal model, they want us to find the total cost. So they did that for us. So what's in my total cost here? Well, we got the cost per month, right? Now we're doing a verbal model, so we're putting in givens and variables. They actually this is a given cost, but it's still verbally it's the cost per month, right? Even though it's given, we're just making the verbal model, so we're going to keep it, and then we're going to add to it the $17, right? So the cost of each hour. And again, that's given. The part that's not given is how many hours, right? So we're going to multiply it by how many hours. Oh, I should just put number of hours. So that's kind of what we don't know. So that's probably going to be our variable, right? Okay, so we're going to assign the variables. The total cost, they told us to use C. So the total cost here is C. See, the cost per month, that's given, right? So we don't need a variable. The cost of each hour, again, that was given to us, $17, times each session. We don't know what this is, right? The number of sessions or hours. So that has to be our variable, which is H. So now we're going to do our algebraic model. So this should be, with all this information, now your algebraic model is pretty easy to put together. Our total cost, C, equals the cost per month. Now we know what that is. That's given, right? That's $20 plus the cost of each hour. That's given, $17 times the number of hours, and that was our variable. So we just made everything a whole lot easier by doing all this other work. All right, so they give us, they say, okay, go ahead and solve this when H is 7. So all we have to do is figure out our final cost is plug in, substitute in 7 for H. And if you plug all of that into your calculators, you get 139. Questions, comments, concerns? Okay, let's throw in another one. Let's do another one where they throw in a wrench. Okay, let's do number 4. Your team is setting up a computer program for a popular coffee store. At this store, if you make a single $4 donation, each drink costs $2.40. Here's the wrench. But the first 3 drinks are free. So that's what they're throwing in that's different in this word problem, right? So our verbal model is going to pretty much be the same. They want to look for the total cost. That's going to equal, well, they got a donation here, so we have to make a donation, right? That's going to be part of our cost. So we're going to have to add to it the actual drink cost, right? Or cost of drinks. We're going to have to multiply that by how much each drink is, right? By the number of drinks, sorry. But we got to deal with that wrench they threw in with us, right? Okay, so I'm taking the drink cost, the cost of the drinks, and I'm multiplying it by the number of drinks, but we get the first 3. And they're telling everyone's going to at least order 4 drinks. So how am I going to represent those first 3 free drinks out of this number of drinks? Yeah, okay.
You subtract 3.
Yep. So I subtract the first 3 drinks. Now, now I was multiplying 2 numbers together, right? But now, which was okay because that was one term. But by subtracting this 3, what did I do to the one term? I made it 2 terms, didn't I? So what am I going to need in between? What am I eventually going to need here? Anybody see it? I have a number being multiplied to 2 terms. Parentheses, right? Eventually, somewhere down the line, I'm going to have to use the distribution property, the distributive property. Good. So let's assign our variables, and I think they told us, didn't they? T is going to represent the total cost. So here's my T. And C to represent the number of drinks ordered. So this is going to be my C, the number of drinks. Okay. Should make our algebraic model pretty easy then. So I got T equals, now I'm putting in the numbers, the values. The donation is $4 plus the drink cost, which is $2.40. Now I'm going to put in my parentheses because I'm going to have to distribute the number of drinks, which is C, minus 3. Should we do another one of those, or you guys good? You want to start your homework? Done listening to my voice? You don't like me anymore? Boring? You're sleeping like Doug? Huh? You're done? The whole packet? Do you want to go into honors algebra too? And I'm not being sarcastic or anything. If you're done with the packet, maybe this course is. Think about it. You got till tomorrow, okay? Yeah, if anybody's blowing through this stuff and finished it, you might want to think about honors algebra too. And I'm not being sarcastic or anything. It's real.